All right, here we are going to be reviewing linear equations and inequalities and how to solve them. So the first thing we want to go over is the different kinds of rules we can use when solving a linear equation. So when you want to solve the linear equation, there is the addition and subtraction rule. You don't have to know it by name, but pretty much what it says is that you can add or subtract the same number from both sides of the equation. So if I have a problem like this where you have x minus 6 equals 2 and you want to leave the x by itself or you want to solve for x, all you have to do is do the opposite of what is here. So if I have a minus 6, you have the right to add 6 to both sides. But remember, you have to, in order to keep equality, you do it to both sides. I add a 6 on this side. I add a 6 on this side. And I know some of you are like, I already know how to do that. Let me just go ahead and show you real quick, right? These cancel out. And of course, on the other side, you do have to do 2 plus 6, which would just give us the 8, right? So that's just something you can do. The other rule that applies is the multiplication or division rule. So this one says the same thing as the last slide, but on this one, what it says is that you can multiply both sides of the equation or you can divide both sides of the equation by the same number, but it has to be a non-zero number. So just be very careful with this one. You can multiply or divide by any number you want besides 0. So when you have something like this, where you have a variable being, if it's next to a number, it means multiplication. So if you can multiply, you do the opposite. So the opposite of multiplication is division. So I can divide this side by 3. But when you do to one side, you do it to the other, right? These cancel out and you're left with 15 divided by 3, which just simplifies to 5. Okay, so we're just going over the rules of what you can do. Something else that you can do when you run across one of these problems is what we call the distributive property, which can be used to remove parentheses, right? So if you have something like this and you have a number or a variable outside, distributing means that you multiply to everything inside. So if you have more than one thing inside the parentheses, you would have to keep distributing. So for example, in this problem, you have 3 and then you have x plus 7. You distribute the 3 into the x and you also distribute it into the 7. When you distribute, you multiply. So 3 times x gives me 3x and then 3 times 7 gives me my 20. Okay, so in order to solve an equation, which is what we were getting to, you could use any of the rules we just talked about. But just make sure that you always follow the same, kind of the same flow. So first thing we're going to do is we're going to distribute if needed. If your problem has parentheses, we are going to distribute. In order to solve a linear equation, you have to move all your variables to one side. So that's an important thing. Make sure all your variables are in one side of the equation. Everything that's not a variable is going to go into the other side. You're going to have to isolate your variable. Isolate means you're going to have to leave your variable by itself. And then you could use the multiplication rule of equality. You could use the addition. We always use the addition one first. So always get rid of all the numbers and then we divide whatever numbers in front of the variable at the very end. So here we have an example, right? So let's go ahead and just follow the flow. So first we have to distribute, but there's no parentheses, so we skip that step. Second thing we do is we have to make sure the variable is on one side. So the 5x has to be with the 3x on the same side of the equation. So somehow I'm going to have to get them together. And the negative 7 is going to have to go to the 1 because, again, they have to be on the same side. Some of you are going to choose to throw the x's to the right side and the numbers to the left side. Some of you are going to do it backwards. It doesn't matter as long as the numbers are together and the x's are together. So what I did is that I moved the 3x to the other side. So what I did is I subtracted 3x from both sides. So if it came to this side, it became a negative 3x. And then the negative 7, I added 7 to both sides. So when it ended up being over here, it became a positive 7. So look what I did. So again, the whole point is to have the x's on one side, the numbers on the other. And then simply, all you do is just simplify. So 5x minus 3x gives me 2x. And the 1 plus the 7 gives me the 8. Of course, you're not done because isolate means that the x is by itself. It's being multiplied by 2, so I do the opposite of multiplication. I divide both sides by the 2 because that's a number in front of the x. And that will give me my final answer, right? These cancel out. 8 divided by 2 gives me my 4, which is my final answer. All right, we're going to work on several examples now just to make sure that it's making sense. So look at this one. I wanted to throw a fraction in there. Just to help you and guide you on what to do. So when you have something like this, remember the 7 is right under the x. So what you want to get rid of first is anything outside, or not outside, but far away from the variable. So how do I get rid of a 6, of a negative 6? I add it. Since it's being subtracted, you always do the opposite. The opposite of subtraction is addition. So I add 6 to this side. Of course, if I do it to the left side of the equation, I have to do it to the right side of the equation. Okay, so remember, just making sure we know how to do all of this. So these cancel out, and I'm left with a fraction, and then 2 plus 6 gives me the 8. Now, don't freak out. This is a fraction, but pretty much what is happening, you should know that this means division. So x is being divided by 7. So in order to get rid of it, I do the opposite of division. So divided by 7, I do the opposite, which means multiplication. But what I do to one side, I come and I do it to the other. Those cancel out. 8 times 7 gives me my 56. Okay, so again, they're fractions, but don't let them scare you. You know how to get rid of them. All right, a scarier fraction. Again, we tackle it the same way. We have a 7 next to the x. We have a 2 on the bottom, and then we have a negative 2. Remember, you always start with the thing farthest away from the x. So let's go ahead and get rid of this 2 first. So the opposite of subtraction is addition. So I'm going to add 2. To the left side, I'm going to add 2. To the right side of the equation, of course, these cancel out. So I'm left with 8 plus 2 gives me 10, and I'm left with this ugly fraction over here. Now, we have a 7 and we have a 2. What do I get rid of first? And yes, it's important. You have to do it in order. If not, you're going to get the wrong answer. So again, the x plus 7, the 7 is right next to the x. So we have to get rid of the 2 first. So now this right here means division. Just like in the last problem, what's the opposite of division? Multiplication. So I do times 2. I do times 2. These cancel out. 10 times 2 gives me my 20. And then look at that. I'm just left with this right here. That's it. And hopefully you know what to do from here, right? What's the opposite of plus 7? Means minus 7. So what would be my final answer? What is 20 minus 7? That would give me 13. Look at that. That wasn't that bad, even though it looked scary at the beginning. All right, no more fractions, but on this one, we do have parentheses. So remember, the first thing you want to do is get rid of those parentheses. So when you have something like that, whatever is outside the parentheses, you distribute. So I'm going to distribute here. And please do not distribute all the way to the 8 because the parentheses closed here, that's it. That's the farthest most I'm going to distribute. So negative 7 times negative 9y gives me 63y. Negative 7 times negative 1 gives me positive 7. The 8 comes down because we didn't touch it. It wasn't inside the parentheses, and that just comes down. Now, before I move on, I know you want to start moving things around, but in order to make our life easier, let's combine like terms. On this side of the equation, I could combine the 7 and the 8. Please do not combine it with this one because this one's on the other side of the equal sign. So 7 plus 8 gives me 15. Now, let's see. The 15 doesn't have a y, so might as well just move it to the other side. So if I'm going to move it to the other side, I do minus 15 because I do the opposite. Remember, the opposite of adding 15 is subtracting, and I have to do it on the other side as well. These cancel out. Negative 300 minus 15 gives me negative 315. And 63 is being multiplied with a y. I'm sorry, that's supposed to be a dot. So since it's being multiplied, do the opposite. So I divide by 63. And now I have no idea what that is. So you would pull out your calculator, right? Negative 315 divided by 63, that gives me my final answer of y equals negative 5. So just make sure you're following the steps in order because that's always going to be important. Get rid of the parentheses, combine like terms if possible. In this little step right here, please do not get rid of the 63 first, right? We had to get rid of the 15 because that's farther away from the y. Get rid of that first, and then you could get rid of the 63. So make sure you follow the order correctly. All right, this one's a little more interesting, right? We have a fraction, we have parentheses, we have x's on both sides of the equation. How in the world do we start? Well, let's go ahead and see what we could do first, right? So what we're going to do first is when you have a fraction, like this one, it's being divided. Remember, we always get rid of whatever's farthest away from the x. So since it's being divided by 5, we do the opposite. And don't let it scare you. I know it looks scary, right? So the opposite of dividing by 5 is multiplying by 5. Now be very careful. We're going to multiply this side by 5, and we're going to multiply this side by 5. But be very careful. What am I multiplying by 5? The 2x or the 6? The answer is both of them. So make sure you put parentheses, put a little star on your notes. You have to make sure you put parentheses because you're going to multiply the 5 times both of them, times whatever was on that side. Now the cool thing is that on this side, if I multiply that by 5, these cancel out. So I'm just going to be left with this. Now if I multiply both of these by 5, that's going to give me 10x plus 30. Okay, so look at that. On this side, the 5's canceled out. I was just left with 3, whatever was on the numerator. And then on this side, both of them were multiplied by 5, so the 2 and the 6 became 10 and 30. Now, this is much prettier. There's no more fractions, but there is parentheses. Remember, every time you see parentheses, means we're going to distribute. That gives me 3x plus 9. And of course, on that side, we still have that. Now, from here, you should know what to do, right? The x's have to be on the same side of the equal sign, and the numbers have to be on the same side of the equal sign. So what I did is that I moved the 3 to this side. So I'm going to have 10x. And then the 3, if it moves to the other side, it's going to become a negative 3x. I am so sorry about my handwriting. And then the 30, since it's a number, I want it on this side with the other number, which was 9. So 9. And then the 30, it's positive, so if it comes to this side, it's going to become negative, so minus 30. That is how I got the next step. 9 minus 30, that's how I got the negative 21. And then 10x minus 3x, that's how I got the 7x. All right, we're almost done. Now, and again, don't forget the x's on the left side, sorry, on the right side. We're normally used to seeing it on the left side. That's okay, don't worry. The 7 is being multiplied, so the opposite of multiplication is division. I divide by 7, I divide by 7. Just pretend those are pretty 7s. 7 and 7. And then negative 21 divided by 7, that gives me negative 3. Okay, and again, this is the same thing as saying x equals negative 3. We're so used to seeing the x on the left side, but these two are exactly the same. All right. Okay, so now that we went over all of those, we're going to go over equations that have more than one fraction. So right now we tackled some problems, but they only had one fraction. What if a problem has two fractions? So this is what you're going to do. If you ever run across a problem that has two fractions, you're going to have to find what we call the least common denominator, which is LCD. And then once you find your least common denominator, you're going to multiply all terms by that LCD. It's going to save your life because it's going to make the problem so much easier. Okay, so before we do that, let me just go ahead and go over how to find the LCD. So if you have, let's say, these two fractions, the least common denominator means a multiple, the smallest multiple of the two denominators. Who cares about the numerators? We're just focused on the denominators. So the way you would do that, and again, some of you guys are going to be really good at finding the LCD. By all means, go for it. Some of us are going to have to write down the multiples until we find it. That's perfectly fine too. So what we do is that we're going to list all the multiples of 6, which means the multiplication table, right? 6 times 1, 6 times 2, 6 times 3, and so on. And the multiples of 8. 8 times 1 is 8, 8 times 2 is 16, 8 times 3, and so on. And then you look for the smallest number they have in common, which in this case would be 24. That is how you find the LCD. Now this one wasn't an actual problem. I just wanted to make sure we knew how to find the least common denominator because it's going to come in handy for problems like this one. So in this one, you see we have an equation. It has two fractions. So first step is just don't panic. And then step 2, find the LCD. So the LCD of 2 and 3, some of you are going to be able to right off the bat tell me, oh, the LCD is 6. Awesome. If you do not know what the LCD is, just use this method we talked about in the last slide. Look at the multiplication table for 2, the multiplication table for 3, and look for the number they have in common. All right, the cool thing is that now that you found your LCD, what you're going to do is you're going to multiply all of the equation by that number. So if you notice, I put the whole equation in parentheses and then I multiplied by 6. Okay, I know you're like, what is she doing? It's just going to make the problem worse. It looks disgusting, but it's actually going to end up being very pretty. So when we multiply by 6, it's going to get rid of all the fractions. And this is what I mean. What you're going to do is you're going to multiply every single number by 6. I'm going to multiply this fraction by 6. I'm going to multiply that fraction by 6. And I'm going to multiply the 1 by 6. So all I did was I give each one a 6. Okay, I'm just doing baby steps. You don't have to write this down, but I want you to know what's happening. All right, now make sure you pay attention to this. What you're going to do is that you're going to divide these two numbers. That is how you're going to multiply. I don't want you to distribute the 6 to the x and to the 5 and to the 2 because it's going to give you a lot of trouble. So just remember, just divide these two. So what is 6 divided by 2? 3. And the numerator, you don't even touch it. I just left it like that. Same here. What is 6 divided by 3? 2. And look at that. The numerator, I didn't even touch it. I just wrote it down. Now this here doesn't even have a fraction, so I just multiply that. 6 times 1? 6. And then look at that. You're very welcome. I got rid of the fractions. So now all you have to do is just solve this problem. So here we know we have to distribute. 3 times x gives me 3x. 3 times 5 gives me 15. I distribute here 2. 2 times x is 2x. 2 times 3 is 6. So that's how I got these two. And then the 6, there's nothing there, so I just brought it down. And look at that. From here, you should know what to do. Combine like terms. 3 plus 2x gives me 5x. 15 plus 6 gives me 21. And please do not combine it with this 6 because this 6 is on the other side of the equation, so I just leave it there. From here, you should know that now we move the 21 to this side, and it becomes a negative 21. So 6 minus 21 gives me negative 15. And then from here, we simply divide by 5. That's not an S. That's a really nasty 5. And then that gives me my final answer, which was negative 15 divided by 5, which is negative 3. Okay, so again, now you know how to get rid of multiple fractions. So if you have a problem with more than one fraction, remember, find the LCD, multiply everything by that LCD, and it will get rid of the fractions for you. All right, you have made it to the last part of this topic. So now that you know how to solve equations, we're going to now go ahead and solve inequalities. To solve inequalities, you can do the same thing we've been doing. So you can add or subtract the same number from both sides. You're still free to do that. You can multiply and divide both sides by the same number. Just make sure it's not 0. But make sure you put this on your notes. This is very important. If for some reason you're solving a problem and you decide to multiply or divide by a negative number, you can totally do it. But just remember, if you ever do that, if you ever multiply or divide by a negative number, your inequality sign is going to flip. Please remember that. And it's only when you multiply or divide by a negative number. Okay, and we're going to see some of those problems right now. All right. Something else you have to know. You have to know several things before we tackle problems. When we're solving inequalities, these are the 4 different types of inequalities you're going to see. If you don't know how to read these, make sure you write it down in your notes. This one right here is less than. It kind of looks like an L for less than. This one right here is greater than. This one right here, it still looks like a less, so it's less than or equal to. And this one right here is greater than or equal to. Okay, so I just went ahead and told you how to read them. Make sure you put that on your notes if you think you're going to have trouble. Now, for solving inequalities, we have to know several things. When you see these two signs on your problem, we are going to use an open circle when we're graphing. And again, I know that makes no sense, but don't worry. I'm going to show you in a little bit what I mean. And make sure you also write this down. When you see these signs, you're going to use parentheses. That's very important. Okay, so again, when you have these two signs, you're going to use parentheses. All right, now when you see one of these two signs, these ones are ones that have the equal sign on the bottom. When we graph, instead of using an open circle, we're going to use a closed circle, which is going to be a shaded in circle. And very important, when you do interval notation, we're going to be using brackets. So this is how you distinguish when to use parentheses and when to use brackets. Depends which one of these symbols you have. And again, this makes no sense. We're going to work on a problem in a little bit. All right, one more very important note. regardless of what sign you see, if you ever use a negative infinity or a positive infinity, you're always going to use parentheses. All right, and yes, I am exaggerating because when you see one of these symbols, you are going to use parentheses. You never put a bracket here. You always put parentheses. All right, and again, I'll tell you what I mean in a little bit. All right, let's go ahead and tackle some problems now. So look at this one. Graph the inequality and then give its interval notation. I want to know and I want to make sure you guys know how to write interval notation. So first thing you're going to do is read this. How do you read this? X is less than or equal to negative 3. So look at your notes. If I graph this, because they're asking me to graph, am I going to use an open circle or a closed circle? So I'm going to pretend you said it right. So very good. Yeah, when you graph this, we used a closed circle. So shade it in because it has an equal to. And then it's a negative 3. So we start at negative 3 and we do less than negative 2. So less than is always to the left side. Okay, so that's how you graph, super easy. Start at negative 3 and less than. And pretty much what one of my students told me is you could just pretend this is an arrow. It's pointing that way, so that means you're going to shade that way. All right, this is the important part. I want to know you can give me the interval notation. Interval notation is you telling me where the graph is shaded. So this is going to keep on shading all the way over here, always and forever. What is over here? If I keep on going, I'm going to reach negative infinity. So that is where the shading starts. Now, where does the shading end? Just like if you were reading a book, this is where it starts. I'm reading, and then it stops right here. It stops at negative 3. And now you have to put brackets or parentheses. Now, look at your notes. When we have this sign, and let me just go ahead and go back. When we have this sign, it says to use brackets. So I'm going to use brackets. I'm going to put a little bracket here. And I'm tempted to put a bracket here, but remember what our notes say. Every time you have an infinity, you always put parentheses. And that is how you come up with your interval notation. Okay, interval notation is just another way of giving the answer, but without shading, without anything, it's just an interval notation. All right, let's try another one. How do you read this? X is greater than negative 2. So what kind of circle are we going to use? An open circle. And what side are we going to shade to? It's pointing that way, so we're going to shade to the right side. So I start at negative 2. I put an open circle. I shade this way. Now, what is that in interval notation? Where is it shading? And again, we read a book from left to right. So the shading starts at negative 2. And it ends in, please do not say 5, right? It ends in, it keeps on going all the way to positive infinity. Now, because of this sign, what do I use? Brackets or parentheses? Okay, we use parentheses. So I put a parentheses here, and regardless, this always goes with parentheses, right? Infinities always go with parentheses. So that is my interval notation. All right, just a couple more. We're almost done. Graph the inequality. Now this one is going to give me trouble. I cannot graph it yet because the x is not by itself. So this one we are going to have to solve it. I have to get rid of the 5 and I have to get rid of the 7. Just like we did on the last problems, I have to get rid of the number that's farthest away from the x. So I have to get rid of the negative 7 first. So I'm going to add 7 to both sides. If I add a 7 here, I have to add it to this side of the inequality. So it cancels out here. 13 plus 7 gives me 20. So this is how I got this step right here. Now to leave the x by itself, I divide by 5. So I divide this side by 5. And I divide this side by 5. Oh my goodness, pretend that's a 5. That's a very ugly 5. There you go. That made it worse. So these cancel out and I'm left with this. Now the x is by itself. Now I could graph it. How do you read this? X is less than or equal to 4. So when I graph it, this is what it looks like. I used a closed circle and it's less than, so I shade this way. Now this is the important part. What is that in interval notation? So it's shading all the way to negative infinity and it stops at 4. And do I use a bracket or parentheses? So remember, look at your notes. Whenever you have this sign, we use a bracket. And who cares? Infinities always go with parentheses, right? So that's my answer. Negative infinity to positive 4. And please do not put it backwards. You cannot put the 4 first and then negative infinity. It's always the smallest number and then the biggest number. All right, we have 2 more problems to go. Let's try this one. Again, just like the last one, I have to leave the x by itself, so I'm going to subtract 5 from both sides. These cancel out. What is 8 minus 5? That gives me 3, right? So I'm left with negative 3 is greater than or equal to 3. Now, how do I leave the x by itself? I have to get rid of the number in the front. Since they're multiplying, I'm going to divide by negative 3. And then I'm going to divide this number by negative 3. All right, so these cancel out. I'm left with x. 3 divided by negative 3 is negative 1. But oh my goodness, what happened to this sign? Why is this sign not the same as this one? And some of you are like, oh my goodness. Remember, look at your notes. If I divide by a negative number, the sign flips. So let me do that again. I divided by negative 3. And remember what I told you earlier. If you ever divide by a negative number or multiply, the sign flips. If it has an equal to, it still has an equal to, but the sign instead of being greater than becomes less than. Okay, so again, please make sure you put that on your notes. Don't let that confuse you. If you ever run across one of these problems and you forget to flip the sign, you will be getting it wrong. Okay, so the sign flipped. The x is by itself. This is my final answer. X is less than or equal to negative 1. I used a closed circle because it has an equal to. It's less than. I shake to this side. Final thing I have to do is give the answer interval notation. So this keeps on going forever to negative infinity. It stops at negative 1 because it has an equal to. I'm going to put a bracket. But again, infinities always go with parentheses. So that's how I get my final answer. Okay, so again, from this problem, I just wanted you to see that when you divide by a negative number, or if I had multiplied by a negative number, the sign flips. All right, our last problem here, solve the inequality and then give its interval notation. Again, don't let this freak you out, but it is here for a reason, right? This is kind of like what we talked earlier. An inequality can also have multiple fractions, but you should already know how to do that. Look at the denominators. We have a 2, we have a 3, and we have a 6. You should know when we have fractions, remember what comes to save the day? The LCD. Your least common denominator is the one that's going to get rid of the fractions for you. So what's the least common denominator of 2, 3, and 6? Look at your times tables. Your LCD is going to be 6. So now what in the world do we do? Once you find your LCD, you're going to multiply every single thing by 6. I know this looks scary, but don't freak out. So I multiply this by 6. I multiply this by 6. And I multiply this right here by 6. And again, I already showed you how to do this earlier. So all you do, you don't touch the top part. You just divide 6 by the denominator. So 6 divided by 2 gives me 3. And again, the numerator is still there. The sign stays the same. You just pretend it's not there. And again, divide these out. 6 divided by 3 gives me 2. And the numerator, I didn't even touch it. It's still there, but just don't forget to put it in parentheses. And then do the same thing here. 6 divided by 6 is just 1. So I didn't put it, or you could just kind of cancel them out. It doesn't matter. So I'm just left with the 5. And then from here, you guys are experts on this, right? Distribute. That gives me 3x minus 54. 2x minus 18. And then the plus 5 stays there. Let's combine like terms, right? So negative 18 plus 5 gives me negative 13. And then the 2x, I moved it to this side. So it became negative 2x. The negative 54 that was on this side, I moved it to this side. And it became positive 54. Okay, hopefully I didn't lose you there. But if I did, just go ahead and rewind. But that's what I did, right? So I combined like terms and then I moved things around. If you're asking yourself, why didn't she switch the sign? I didn't switch the sign because we never divided by a negative and we never multiplied by a negative. I just moved stuff around. Now we just complete this here. 3x minus 2x gives me 1x. 54 minus 13 gives me 41. And then look at that, that's my final answer, but they're asking us to give the answer in interval notation. They're not asking us to graph it, so I'm not going to graph it. But how in the world do you convert this into interval notation? Some of you are going to be able to do it right off the bat. Awesome. For me, I'm going to graph it real quickly, just because it's going to help me. So I'm going to start at 41. And now this means greater than or equal to. So I'm going to put a dark shaded in circle. Greater than means shade this way. Again, I'm so sorry. Pretend this is shaded. And that helps me because I see that all the way we have positive infinity, and I know I started at 41. So since it's a closed circle and we have an equal to, I'm going to put a bracket. The shading starts at 41. And it goes all the way to positive infinity. And we know that infinities always go with parentheses. So that is how you find the interval notation. So make sure that you know how to solve the problem and that you know how to write it properly.